How does DeepSeek harness work? It breaks an AI agent's capabilities into plugins. This episode gives you a screenshot-ready DeepSeek harness source reading map. Instead of guessing through the repository folder by folder, use 4 entry points to see how plugins are assembled, advanced, recorded, and released. In August 2026, DeepSeek AI released immutable DeepSeek harness DSH v0.1.0 RC7. This episode is pinned to that release and its source commit. This remains a developer preview with possible compatibility breaks. The RC7 map does not prove quality, performance, security, reliability, or production maturity. This video is packed with practical, high-value insights to help you get better at using AI. It's a longer one, so follow TinyAgent and save it so you don't lose it. Open the base bundle first so you can see where a DeepSeek harness runtime starts assembling itself. Packages/bundle/base/Cordis. Patch. YML is more than a feature list. One insert creates the root configuration, then named IDs mount models, sessions, the agent loop, tools, approval, sandboxing, persistence, and other plugins into one tree. Remember the patch behavior. A later row with the same ID replaces the earlier row, and its config is replaced as a whole rather than deep merged by default. From a source reading perspective, LLM, session, agent loop, and tools are separate mount nodes rather than one giant initializer. Approval, sandboxing, and persistence can each be traced from their own node into an implementation package. That gives the base bundle 2 jobs. It is the default runtime assembly and an index from capability names to source packages. So do not begin by diving into every package. Use the base bundle to answer 3 questions: which plugins are mounted, which IDs identify them, and which settings a later patch can replace. That assembly table is the source map's index, but it does not show how a task moves. The next stop is the agent loop. Chapter recap. First, the base bundle is the runtime assembly entry point. Second, named IDs and patches compose plugins into one tree. Third, configuration replacement is whole row behavior, so later patches still matter. Next, open the agent loop so you can trace how one input becomes model steps and tool execution. In packages/core/agent loop/src/agent. TS, turn first appends turn/start. Prestep then claims the inbox, assembles the prompt, and appends step/start plus user messages. Step derives model messages from the session, builds the request, and streams the response. The assistant message is appended, and any tool calls inside it move into the tool execution path. Streamed chunks first become a recoverable assistant response, then actual tool calls are filtered from the completed message. What the model said and what the runtime executed are not collapsed into one transient callback. Execute tools hands those calls to the tool layer and appends their outcomes to the session. The next step still rebuilds its request from session facts. If more work remains after those tools, the loop enters another step. With no further tool calls, the turn closes. The loop owns when work advances. It does not re-implement every capability. Connect turn, prestep, step, and execute tools to see the control flow before reading every event in detail. Chapter recap. First, turn establishes the boundary of one task turn. Second, step derives a request from session facts and writes the model response back. Third, tool calls determine whether the loop continues or closes. Now open session so you can tell which facts model history, recovery, and replay should trust. Packages/core/session/src/index. TS appends events to an ordered log. Append takes a lossless JSON snapshot, validates the surface, assigns a continuous seek, freezes the object, pushes it, and emits the event. Derived messages does not create a second chat transcript. It projects the log in order into model-visible messages, letting requests, interfaces, recovery, and replay derive from one fact stream. Seek is assigned from the current log length at append time, so readers can inspect continuity without guessing order from the interface. Each event object is frozen before it enters the log, preventing a caller from silently rewriting a fact after it was recorded. That supports consistent replay and message derivation. Persistence is not hardwired into the session core. Session/event and session/flush let a plugin own when those facts are stored, while the log itself maintains append-only order. When you ask why the model saw a context item or why recovery diverged, return to the session log instead of trusting only the chat bubbles on screen. Chapter recap. First, the session log is the append-only fact source. Second, model messages are derived from that log in order. Third, persistence belongs to a plugin, so an in-memory log is not proof that data was stored. Finally, open tools to see which checks sit between a model's proposed action and the result that becomes visible. Packages/core/tools/src/index. TS places registered definitions into a scoped registry, then applies restrictions and guards to decide what this context can see and execute. Execute snapshots arguments, runs pre-execute, asks for approval when required, passes a monotonic guard, and wraps the actual tool body through the tools/execute path. Scoped restrictions narrow the tool view first, while guards constrain a call that has already been selected. One answers what the model can see. The other answers whether this action may continue. The around tools/execute boundary wraps the tool body so policy and observation plugins can intercept execution without rewriting every tool implementation. The output still passes its schema, renderer, and post-execute work before becoming normalized content and an appended tools/result. Cancellation and rejection fail closed instead of being presented as success. This chain shows that approval is not decorative UI and a result is not an arbitrary string. Policy, execution, and recording each have an inspectable node. Chapter recap. First, registry scope and restrictions decide whether a tool is visible and usable. Second, approval and guards decide whether an action is released. Third, output validation and tools/result determine which fact remains. Now connect the 4 entry points into a map you can use directly against the RC7 source. Stop 1, base bundle, list plugin IDs, mount order, and replaceable settings to answer what is assembled. Stop 2, agent loop, follow turn, pre-step, step, and tool calls to answer when work advances. Stop 3, session, follow append, seek, derive messages, and flush events to answer what becomes fact. Stop 4, tools, follow registration, restrictions, approval, guards, execution, output validation, and tools/result to answer who can release an action and how its result is recorded. Together they form the shortest reading path. Configuration chooses the capability set, the loop advances work, the session preserves facts, and the tool chain constrains actions. The map explains the current RC7 implementation. It does not prove that plugins are the only or superior architecture, and it does not replace compatibility, permission, failure, or performance testing. Screenshot this map and use its 4 stops to inspect the source. Chapter recap. First, use the base bundle to build the index. Second, connect control flow and fact flow through the agent loop and session. Third, use tools to validate policy, execution, and result recording. How does DeepSeek harness work? It breaks an AI agent's capabilities into plugins. It starts by assembling plugins through the base bundle, advances work through the agent loop, records facts in the session, and routes restrictions, approval, output validation, and result recording through the tool's execution chain. The source reading map explains the current DSH v0.1.0 RC7 implementation. This is still a developer preview with possible compatibility breaks, and attention does not prove quality, performance, security, reliability, or production maturity. When you read an agent project, do you start with configuration, the runtime loop, the session log, or the tool execution chain? Share your order in the comments. Follow Tiny Agent. Tiny Agent helps you get better at using AI.